The atomic masses of all of the elements that are listed on the periodic table are all based on a standard, and that standard is the carbon 12 standard. When you count the number of atoms in 12 grams of a pure sample of carbon 12, that number of atoms works out to be 6.022 times 10 to the 23rd, which is called Avogadro's number, which is also called a mole of atoms. So the value on the periodic table, the atomic mass, is also the molar mass. The value is exactly the same, but we change the units from AMUs, which are not very useful in the chem lab, we change them to a more useful unit of grams. So for example, the value for carbon on the periodic table is 12.01. That means 12.01 grams of carbon are equal to 1 mole of a naturally occurring sample of carbon that contains all of the isotopes of carbon. That means we now have a new conversion factor. We can turn moles of atoms into a mass, or we can turn a mass into moles of atoms. So for example, we can calculate the number of carbon atoms in 3.5 pounds of graphite using that periodic table value. So the unknown we're trying to calculate is the number of carbon atoms. The known is 3.5 pounds, and we can turn pounds of carbon into grams of carbon. Then we can turn grams of carbon into moles of carbon, and moles of carbon can be turned into a number of atoms. The pound to gram conversion, 1 pound is just under 454 grams. Grams of carbon into moles of carbon, we get this conversion factor from the periodic table. The molar mass of carbon, 1 mole of carbon, the value on the periodic table, 12.01 grams. And then 1 mole of anything is always Avogadro's number, 6.022 times 10 to the 23rd atoms of carbon. So multiplying this out, we get a huge number, 7.96 times 10 to the 25th atoms.